Algebra students, in this lesson we're going to be talking about how to simplify complex fractions. Now, what is a complex fraction? It's a fraction divided by another fraction. Or more simply, there's another form that these can take. It's a symbol, a math symbol that involves two or more fraction bars in the same expression. Okay, so let me give you an example of this. A over B divided by C, even if I didn't have this fraction on the bottom, would still be a complex fraction because they have two fraction bars in the same expression. Now, this looks complicated and it's called complex, but really, you have the tools that you need to deal with this. All right, and the tool that you use to deal with this is keep, change, flip. Because you know what? The fraction bar is just a symbol indicating a division. So all we're doing is actually dividing two fractions by each other. A over B over C over D can be rewritten as A over B divided by C over D. And you know how to deal with this. We just use keep, change, flip, where it's A over B times D over C times the reciprocal of the second fraction. And that's how we're going to solve all of these. Okay, so I'm going to show you in one of these why that works, why keep, change, flip works. You can understand that now that we can understand algebra. But I'm not going to encourage you to work things any way than what you're familiar with. And I think that you're probably all familiar with keep, change, flip. So that's what you should definitely use. Let's go ahead and work letter A. In letter A, I have x over 4. So I'm going to turn that into a fraction. There we go, x over 4. And that's going to be divided by 3x minus 3 over x. But wait, I'm not going to divide it by anything. We're going to do times, I'm going to use the asterisk as my time symbol to keep things straight here, times the inverse of the bottom fraction. So I change the sign to times and flip the bottom fraction. It becomes x over 3x minus 3. Let's see, I'm going to try to give myself some room here. X over, and then 3 times x minus 3. All right, now I am going to have to multiply these together. I'm going to have to look and see if there's anything that I'm going to be able to factor out of this. I don't know. It doesn't quite look like there's any easy answers to what we would factor out of this expression. But let's see if we can figure it out. So this is going to equal, and I'm going to multiply across the top and multiply across the bottom. On the top, I have x squared. Okay. So that's pretty straightforward. And then on the bottom, I'm going to multiply 4 times 3x minus 3. Now, I got to be honest, I'm not sure off the top of my head what format they're going to look for the answer in. But let's see, 4 times 3 is 12. And then I'm just combining those factors. It's going to be 12 times x minus 3. There's absolutely nothing that I can factor. You may be tempted to cancel this x on the bottom with one of these x's on top, but remember, the x has to be in every single term for it to actually cancel. And because it's not combined with the 3, there's nothing I can't pull that x out front and then cancel it off. And I don't have any constants on top, so I can't cancel out any constants on the bottom. I believe this is going to be it. Let's just check. X squared over 12 times x minus 3. If I wanted to, the only thing I could do to simplify that is multiply the 12 and distribute it in the parentheses to get rid of the parentheses. Technically, that would be a little bit simpler, but we're not going to worry about that. We're just going to show all the factors and that none of these are going to cancel. And that is how you do these sorts of problems. It's just a keep, change, flip problem. All right, let's go on to letter B. And as we do letter B, this is the one during which I'm going to show you why keep, change, flip works. In case you don't know why keep, change, flip works, we're going to develop an understanding of that in this problem. All right, here we go. First thing we're going to do is get rid of, there we go. All right, so it's going to be B over CD. Let's see. So let me just try to write this whole thing out. B over CD times 2b over c. Okay? Times 2b over c. Now, hold on a second. I would prefer to just be able to write this as a keep, change, flip. How is it that we can get rid of this denominator in this fraction? Is there anything we could do to get rid of the denominator in this big fraction, the entire complex fraction? Well, okay, if I want to get rid of a fraction, what do I do in an algebra problem? I multiply it by its reciprocal. So in this case, I would multiply by 2b, let's see, c over 2b, c over 2b. And that's going to give me, okay, so when I multiply a fraction by its reciprocal, it ends up being 1. So when I multiply this fraction times this fraction, the two b's cancel out, the c's cancel out, I'm left with just 1 in my denominator. But here's the thing, you can't just multiply the denominator of a fraction by something. Remember, earlier on, we learned that when you multiply by something in the denominator, you have to multiply by the same thing in the numerator. Okay? So this is going to be, what I'm actually multiplying is c over 2b over c over 2b. I'm multiplying by a complex fraction because I have to multiply the top by the same thing as the bottom. Now, what is the effect of this going to be? The bottom is going to completely cancel out. But then what am I left with? Do you see that I'm left with the top fraction times the reciprocal of the bottom fraction? This is why keep, change, flip works. Is when you do keep, change, flip, what you're acknowledging is that we need to multiply by the reciprocal of this bottom fraction. And I'm going to multiply top and bottom by that. It's going to completely cancel out this bottom part of the fraction. And I'm just going to be left with the top fraction times the inverse of the bottom fraction. That's what keep, change, flip does. So in case you were wondering, that's how it works. Now, I'm just going to look here and write my work over here. This is going to become BC on top, B times C, over 2BCD on the bottom. 2BCD on the bottom. And then I'm just going to look and see, is there anything that cancels out of this that I have exactly the same in all terms on the top and all terms on the bottom? Well, B is there, so I can cancel out a B. And C is there, so I can cancel out a C. When I cancel out everything on top, I have to put a 1 in its place. It's implied. And I'm going to cancel out the C on the bottom. So the answer for letter B should be 1 over 2D. Letter B checks out onto letter C. And here I've set up letter C for us already. So notice I have 4x squared over x minus 3. I kept that fraction. I changed the sign. Instead of having this division fraction bar, I now have a multiplication symbol. And I flipped the last fraction, so it's 3x minus 9 over x. Now, how do I go ahead and simplify this? Well, I need to see if there's any common factors that I could pull out. I have this x minus 3 on the bottom of my first fraction. I wonder if there's an x minus 3 on top as well. I'm going to pull a 3 out of 3x minus 9. So it's going to be 3 times x minus 3. If I redistribute this, notice it changes back into 3x minus 9, so I know I did that right. Well, would you look at that? It appears that x minus 3 cancels out of my fraction because it's a factor that's on the top and the bottom. And it's multiplying everything on the top, so it's just going to cancel. Also, this x is going to cancel on the bottom with one of these x's. So I'm just left with 4 times x times 3. And when I go ahead and simplify 4 times x times 3, I find that my answer is just 12x for letter C. Make sure we did that one right. There it is. And then finally, letter D. In letter D, I have a pretty deep complex fraction here. Now, notice that on top, I have a fraction plus something. And then I have a fraction minus something on the bottom. It would really be nice if this was in the same form as letter A, where I have just one fraction on top. My entire term is a fraction. My entire term is a fraction on the bottom. So what I need to do with this one is combine what's on the top into a single fraction, combine what's on the bottom. We're going to do that using our rules for adding and subtracting in rational expressions. So on top, it's going to change from 1 over m plus 5. I'm going to multiply the 5 by m over m. M over m is just 1. So I'm actually just multiplying the 5 by 1. When I multiply 5 times m over m, it becomes 5m over m. Hey, and I can add these. Now that I have 1 over m plus 5m over m, that becomes 1 plus 5m over m. Let me just start a new line, and now we're going to use our actual fraction notation for it. So it's going to be 1 plus 5m, and then this 5m is this whole thing, the whole fraction, because I added these two, this whole thing is going to be over m. Okay, now that's just what's on top. This is still being divided by 2 over m minus x over m, but notice I already have a common denominator there. So it's actually 2 minus x over m. 2 minus x over m. Let me just write that out here. So this is the same as 2 minus x, the expression, over m. And I'm dividing by this 2 minus x over m. So actually what I'm doing is I'm inverting and multiplying, or I'm change flipping. Keep the first fraction, change this division symbol to a multiplication, and then flip this fraction here times m over 2 minus x. Confused me for a second that there's an x in there, but there actually is an x in there. Okay, so we just have to remember that. I'm going to put that on the bottom over here, 2 minus x. All right, now I wonder what's going to cancel out of here because I have two variables. That's not good for canceling stuff. But one thing I notice is I have an m on the bottom here that's going to cancel out this m on the top that's multiplying 1 plus 5, right? So this is in parentheses, 1 plus 5 times m. M is a factor of everything on the top. M is a factor of everything on the bottom. It's going to cancel out. None of the rest of this will cancel because there's no way for me to factor out anything on top to make this simpler or on the bottom, and I have different variables anyway. So the end result is going to be 1 plus 5m over 2 minus x. Let's make sure we did that right. There it is.